Hey everyone, this morning I'm working on a board. It's a A1398. It's a late 2013 15-inch Retina, and this board was sent in to us with the issue of having no display. And you know, some of these Retina boards I did another video on where it was the GPU V-Core chip, which was pretty common in the late 2012, early 2013s. Not so much in the late 2013s, especially the ones with the integrated graphics. Now the ones with the discrete graphics that has the two chips, has a separate GPU, those still can get the GPU V-Core issue, but the ones with the integrated graphics where it's the CPU and the GPU in one chip, it doesn't really get the GPU V-Core issue with these. So it was interesting to find out what was wrong with this one, and we're going to narrow it down together and see if I can show you the schematics here, and we can pinpoint what the issue is. First of all, I'm going to go ahead and plug in the power, and we're going to plug in a display just to see, you know, what we get if we are getting an image or anything like that. It's always good to confirm what you're getting in comparison with what the customer was getting, because many times I've gotten a board in where they send a board in only, and they say there's no power. So I'd be like, okay, instead of just immediately start working on it, it's best to figure out if you're having the same issue. So I would plug in the power to it. It would power on. It ran fine. And the issue with that was, you know, it was something else with their unit, either the keyboard or they have another component that they're plugging into their logic board that was keeping the logic board from powering on. So we had to get the customer to send the whole unit in that situation. Anyways, that's just one reason that you want to check the whole board yourself to make sure that you're having the same issues and same diagnosis that the customer figured out they were having. So I'm going to go ahead and plug in power. Get the camera moved down so you can see. And you can see the fan is spinning up. We have a light on the adapter, but we're not getting anything backlight wise on the display. I'm going to let it run for just a moment and see if we are getting anything like any image on the screen at all. In just a moment, if we are, a little folder with a question mark in it will pop up. It's not hard to see in this display. What you can do as well is turn the light on your phone and shine it through, which I am shining, and typically you're going to get, you know, be able to see the backlight or see the light through the screen there because you have the Apple logo on the back that's clear and it shines the light through, but we're not getting anything. So when this happens, typically the screen is completely black. You know, when it boots up, it has a black screen. So this might be the case with this. So we might be getting a display, just no backlight. So we're going to let it sit for just another moment and see if we're getting anything on the display at all. Yep. Okay, so you might be able to see that. I'm going to turn the lights off in here so you can see. You can probably see that better. You can see the question mark, the folder with a question mark in it there. So we are getting a display. We're just getting no backlight. Okay, so we know that the issue is going to have to do with the backlight rail now. So the customer mentioned they were getting no display. They are getting a display, they're just getting no backlight. So alright, we figured that much out, and now it's time to move into diagnosing why we're not getting any backlight. Alright, so we're going to power off the board. And let's let's examine this under the microscope. Alright, so up here, I'll get you in focus. Up here is our backlight circuitry. And this is our backlight for our display. So we're going to check and see if we're getting power here. The P fuse here is our backlight in for our power to the let me fix the microphone here, make sure you hear me okay. The P fuse, this fuse here, is what lets the power into your backlight circuitry. So we're going to check and see if we're getting 12.6 volts on both sides of this fuse. So I'm going to turn on the screen here so you can see the multimeter. Put it in voltage mode to read voltage. I'm going to take power, take a fan. Alright, get back to the fuse there, and I'm going to plug in the power. And now we're just going to take a measurement. Going to put our black probe on ground, and we're going to touch both sides of the fuse here. So we're getting 12.55 volts, that's good. And on the other side, we're getting 12.55 volts. So our fuse is good. And another way, if you remember how to check that, is to put it on capacitance mode, where it beeps. That shows that when you touch the two together, you have a circuit, and you can do that by touching both sides of the fuse. You see how it beeps. So we know that we have a good fuse there as well by doing that. Alright, the next thing to check for on this particular board, which this happens a lot, is these capacitors here. These four right here. And I'll show you on the schematics what these do. These are all tied into the backlight rail. So you have power that comes in through the fuse. It goes into your LED driver, which senses that you have your display plugged in. It also is what adjusts the brightness on your display when you adjust it up and down. This is what tells you how much power to put out to give to the backlight. And then these capacitors here, I'll show you on the schematics. Let me get you in focus. There we go. Alright. So those four capacitors there, the large ones. Let's go over to our schematics. And here we have our backlight driver. And here is the, let's see, the fuse is over here, the P fuse. It's the F7700. So you have it coming from PB bus G3 hot, which is 12.6 volts. Let me zoom in here and show you that. So this is coming in. You have 12.6 volts coming in, and you have some sensor resistors here that sense the power. Then it goes down to your LED driver, okay, and then here it goes through over here through this diode, and then through these capacitors. And these are the four capacitors that I was showing you on the view here. Let me see if I can find that other view. Let's see. Is it this one? Or is it this one? Could be that. We could use this one too. Alright, so here we have those four capacitors right here. And these are the ones right here, the C7715 all the way through C7717. And what this does is it's a boost circuit. So as you can see, we have 12.6 volts coming in. It goes through your LED driver, and then check out the voltage after the boost circuit. You have 55 volts. So that's the reason this is a boost, is because you need more. You need 55 volts, up to 55 volts, to power the backlight on your display. And so these do that. So let's check and see if these capacitors are good. And the way to do that is with our multimeter. We're going to get this back up here, we're going to put this in resistance mode. And I'm going to touch the red probe to ground, and I'm going to touch, see this side should be ground, which it is. You see how it says 0, that's 0 resistance to ground. And touching this side, we also have a very low resistance to ground, which that's pretty much a direct short to ground. So now, a lot of times, one of these capacitors goes bad. And you can usually tell by looking at it if one is darker in color, or if there's like a solder ball laying next to the capacitor, or if there's a crack in the capacitor, any of those things, and that can cause you to have a short to ground, because it pretty much becomes a wire after a capacitor goes bad. Right now it has a high resistance to ground as a capacitor, but if it goes bad or shorts out or cracks or anything like that, burns up, it pretty much becomes a wire and gives you a direct short to ground. So all the power that should be going to your display to power the backlight would then be running directly to ground, because power wants to go to ground. It likes to go to ground. So if it has an easier path to get to ground than going all the way to your display, it's going to go directly to ground through the capacitor. But looking at these, I don't see anything bad per se with these capacitors. These capacitors look good. So let's go to the board view, and we're going to click on one of these capacitors, and you can see pin 2 is ground, and pin 1 is your PP out, your voltage out to your LCD backlight. So we're going to click on that, and as you notice, see these red lines, this leads us down to here, which is our display connector, and it goes to pin 1 on our display connector, as well as this capacitor here. So we'll check out this capacitor and see if this one's looking bad or burned up as well. So let's go back to the microscope. And so here's that capacitor. Which to the eye looks fine as well. Doesn't look like it's burned up or anything. But as you see, you're still not in focus. Let me try to get you in focus again. Okay. As you see here, pin 1 on our display connector. Let's see if I can zoom in on that at all. Pin 1 looks kind of burned up. Oh, you can really see it if you turn it sideways. You see how it's lighter in color? The rest of the pins look golden, and the pin 1 looks silver. That's typically because it's been burned up. It has had too much, like a surge of power running through it, which changed the color of the pin. And another way to check this out is to turn it on end. So let me see if I can get you a view of what I'm doing here. So I'm turning the logic board on end like this off the side of my desk. I have the microscope hanging off the edge of the desk as well. And we're going to look down in the pin, or in the connector here. And pin 1 is going to be on this side of the connector. So we're looking in the connector. And I don't know if you can see that, but it is melted. Like the plastic around the pin in there is melted. It's kind of hard to show you. It's easier looking through the microscope than it is looking on the monitor. But you're going to have to trust me on that. That is definitely burned up in there. So this is probably the reason we're not getting any backlight. So what I'm going to do is replace this display connector. So we're going to apply some heat. We're going to apply heat to the connector, because it doesn't matter if we burn this up or not. This is a liquid sensor, which I am going to remove, otherwise it's going to melt. just going to apply heat like this and remove the connector. Like that. Alright, now we're going to, let's see if I'm going to go ahead and take off this heat sink because it seems to be in the way a little bit. Just only 4 screws, so give me just a moment as I remove the heat sink. Okay, so now we're going to clean up the area around this connector here. So we're going to apply some flux. Apply some solder. Okay. Now we're going to remove the solder, because we want our new connector to sit flat on the board. Okay. Nice and flat now. And now I have replacement connectors, like in a package like this. Take one of those out. I'm going to clean off this old flux, the cloth and alcohol. And then I'm going to apply some new flux. And then, with some tweezers, I'm going to hold on to this so I don't get the flux all over my fingers. And I'm just going to drop it in place. You can see here on the bottom of the connector, there are these plastic tabs on each side, and that's what the holes in the board are for, so that the connector will not sit sideways. So you can just, once you drop it in place, you kind of press on it, and those tabs go in the holes of the board, so it sits nice and straight. Alright, so what I'd like to do first is apply some solder to the ends of the connector. Just take a little bit, press on it, and apply some right here, like that. And then turn the board so I can work on it a little bit. I'm going to apply some pressure right here on this side. Apply some solder here. I need some more solder on my tip. Right, like that. Whoa, that's a little bit too much. Alright, in this case, it's good just to take some braid and remove some of that solder. Okay. Let's try it again. We're going to add some more flux. gonna go ahead and add flux all over it, like so. That's a more reasonable amount there. And up here. Okay. And now I'm going to apply it to these ground pads on each end. Like that. And now we're going to try to do the drag method, where you can simply just drag your tool. The only thing is these capacitors right here, these filters, get in the way of the drag. You see how you can just drag it like that? And it goes from one pin to the next. It's nice when things work like that. Okay. Just go along and touch it up, make sure everything's good. Alright, let me go ahead and run it through the cleaner real quick, and I'll be right back and get this flux off of there so we can examine the connections. Alright, so we're back here. What we're gonna do to check out the connections is just going to take our tweezers, and we're gonna go along each pin and see if we have any movement in them. So far so good. Yep, we're all good. So they're nice and firm, they're not loose at all. And so now what we're going to do is just plug in power and see if we get anything on the display. Actually, first, let's go ahead and check our short to ground again. Put this on resistance mode. And we're going to touch the red probe to ground. This should be ground. So it is. And this side. And we have a high resistance, or a very high resistance now, the 1.147, which you mean, remember it was 0.008 earlier. So we have now removed the short to ground, which was in the connector. And now let's hook up a display and see if we get a backlight. First I'm going to apply some new thermal paste and put the heat sink on. And get that squared away. Alright, plug in our power. Get a fan. We're going to get our display. We have everything plugged in. Get our MagSafe 2 and plug it in. Alright, we have power and we have backlight. Now you'll be able to see it in just a moment, but the way I tell is by just using my fingernail a little bit and rubbing it, and you can see the backlight show up there where I apply just a little bit of pressure. This is my test display, so I don't mind if I scratch it just a little bit. It's already pretty well worn out. So we're going to wait until we get an icon, the folder with the question mark in it, so you can see that it is truly working. any moment now, Mr. MacBook. Alright, there we go. We have the folder with a question mark in it, being able to show up through the backlight there. So we fixed that issue. Alright, so hope you learned a few things in this video. We've learned that it's important to always diagnose first before we start working on it. Even though the customer may say, hey, I have this problem, it's always best to go ahead and diagnose it yourself to make sure that your diagnosis matches the customer's. In this case, I could have assumed that the customer was meaning they didn't have any display at all. Therefore, I could have gone down a whole different route of trying to repair this, which would have taken longer. So it was nice to know to figure out that it was just the backlight that wasn't working. So I hope this helped you out a little bit. Hope it was entertaining for you. It's always fun to figure out a problem with a board and be able to repair it. It makes you feel good. I know the rest of my morning this morning hasn't been that way as well, so it's nice to have an easy one like this to be able to figure out. So anyways, I hope you enjoyed it. Hope you have a nice day, and we'll catch you next time on the next video.